Okay. So the first one here, Nick, is this first one linear, exponential, or neither? What is its rate of change if it's linear? It's not -6. Be careful, because look at what it's doing on the x. What is the actual rate of change? There you go. It's y over x. So it has a constant rate of change. The answer key for your guys' review for the test will be posted after school today. And then I plan on getting the final review answer key up this weekend.
Sweet. Perfect. There's so many questions on the final review.
I like this too.
How many days are we going to take to go over it? Because you know we're going to need more than that.
Friday, Monday,
Okay.
Tuesday, Wednesday.
Thursday, Friday, Saturday, Sunday.
Then you guys final. You can use both sides. You can write whatever you want on it to help you for the final. Yes, you get to use it. Well, when I'm going over stuff, I'll tell you to add certain things to it. But I won't be able to get to everything because it's a whole semester I'm trying to go over with you guys. So. All right. So lastly, it asks you if you know that it's linear or exponential to write the equation. So we know there's there's actually 3 different ways to write an equation, but we only wrote it if it was point slope or slope intercept. Which form could we use for this one to write the equation, Kobe? Slope intercept. Why can we use slope intercept? Bless you. We already know the y-intercept. So we get y equals something x plus something. What is my slope, my m value, Kobe? We already found our slope. Nick found that at the beginning for us as -3. What is my y-intercept when x is 0? When x is 0, y is 6. You only need to use point slope if you don't have the y-intercept. Okay, the next one there, Grace, what kind of function is that? Why is it exponential? Multiplying by? Yep, it is multiplying by half. Remember that linear is addition or subtraction, and exponential is multiplication. So this is exponential because your growth or decay factor, so in this case a decay factor, so if you remember back to last week when we started learning how to write equations, we used y equals ab to the x power. Nylan, what would that look like for us in this problem here if it's y equals ab to the x power? Remember, a is your initial when x is 0. Do you need a tissue?
Yeah.
Are you cutting yourself over there? Are you okay?
Yeah, my scab just opened up.
Do you want a Band-Aid?
No.
Just take that. Don't touch me with that hand of yours. You can just keep that. Just keep that box. Don't let anybody else have that box. And the b value is your growth or decay factor. So, Nylan, what would your equation be?
Y equals 48.
Be careful when x is 0.
Oh, x is 0, so 24
Times
1/2
raised to the
x.
So are there questions on that one?
How do you do that?
How do I do what?
All of that.
You confused? You need me to go over it? Oh, okay. No, I'm in the middle of this. After the lesson, remind me and I'll let you go. There should be time. All right. The change height of the ball from one bounce to the next if the ball is dropped from a height of 8 feet and the ball bounces to 75% of its previous height with each bounce. Alex, linear, exponential, or neither? Exponential, what are you going to be multiplying by? It's Kobe's phone. Or one of these other two phones that are just plugged in over here. Yeah, it is exponential. 75% or any percent is a multiplication, and that we changed to a decimal. Don't forget that this one is not using the decay formula because it's saying it's bouncing to 75%. It's not 75% of, which is when we have to do the 1 minus 0.75. In this case, it's telling you exactly what it's bouncing to. So, what is my equation, Gabe, for this one then, if it's exponential? Try it. A is your initial height, and B is your factor.
Y equals 8
Good?
times 0.75x
Not just x, but to the...
to the x.
There you go. What do you guys notice about the next table here? It is not in any order, so I'm going to rewrite this so that it's in an order here. Well, it's in the wrong order. It should be going from least to greatest. You can rewrite it so it's least to greatest. There's no rules against that. Why are you talking? So I rewrote it so that my x values are going from least to greatest, so it's easier to tell. Because otherwise, I think what you guys are going to say is neither. You guys aren't even going to, you're going to be like, oh, this doesn't make any sense. It must be neither. But you can't just assume those things. You guys need to put some work into it. That's why we do stuff like this, because the EOC will sometimes do stuff like this. So, from negative 11 to 8 is what?
+3.
From negative 8 to 4 is? Yes. From negative 8 to negative 5 is? Adding 3. Negative 4 to 0 is adding. Negative 5 to negative 2 is? 0 to 4 is? Negative 2 to 1 is? Or positive 4 to 8 is? So is it actually linear? Yeah, this is actually linear. It has a constant rate of change. Remember, it's y over x, so what is my constant rate of change? 3/4. My availability is on the board. I should be here before school every day this week, Monday, Thursday, Friday after school, and I will be at the study slam Friday night, or Wednesday if you guys are going to the study slam.
What time you gonna be here before school? Because I get here at 6:30.
I get here at 6:45.
Yeah, that's fine. Okay.
So just wait. If you wait, I'll be here. Okay? I'm usually here between 6:45 and 6:50. I have to drop my kids off at 6:30. No, that's weird. You're not the first person that has said that, though, so... All right, so do we need to use slope intercept or point slope? We can use slope intercept. Bree, what is the slope intercept form equation of this table? When x is 0, it's the y-intercept. So it would be, what? Negative 5. So we would put minus 5. Okay, questions there before we get into some graphs? All right. For each representation of a function, decide if the function is linear, exponential, or neither. Tell me why, and then we're going to write the equation. So Cameron, that first one there.
It's exponential
Why do you decide it's exponential?
because it has like a curvature.
Good. So we're going to be writing our exponential function. So I'm going to pull some points off of this that I can see. I only can see like 2 of them though, so we'll see what ends up happening here. Andrew Placencia. We know this is exponential, so it has to multiply. So don't tell me add 4. What do you have to multiply by to get from 2 to 6? Okay, so how would you substitute? Look up here. How would you substitute that value in, and what is your a value? What would your equation be? No, a is your initial value. Where's your y-intercept? Look at your graph.
The initial value.
Where's your graph? On your graph, your initial value is your y-intercept. Okay, 2 times what? Huh? 3. That's your growth or decay factor to the what power? Perfect. Okay. Dijonay, what's the next one there? Why is it linear? It's a straight line, left to right, you're right. Doesn't turn or anything like that. So we can write our equation in slope-intercept form, y equals mx plus b. So Andrew Castelli, what's my slope? That's your y-intercept. What's your slope? So it goes up 3 over 1, up 3 over, I skipped something there. So awesome job, Andrew Castelli, on that slope. It is 3 over 1, which is just 3. So Emil, what is my slope-intercept form equation then? Perfect. Okay, questions on those ones before we move on? We only have 2 more slides, and then you guys get to work for the rest of the hour. And you get to go get a drink right away when we're done, Andrew. You may listen to music when you guys are working, as long as you guys continue to be so good during notes like you are. She would never do such a thing. Okay, Dalia, number C is what I almost said. Letter C, linear, exponential, or neither? Neither. Exponentials don't go back up or come back down. That's actually called a quadratic. You will learn about that second semester. So we can't go past that neither situation there. Stop bending your pencil. Stop it. Yeah, you're going to still snap it. They still snap. All right. Maddie, how about the next one? Why is it exponential? It's an L-shaped curve. Very good. Okay, Julian.
Yeah.
We're going to make a table of values to help us figure out what our exponential equation is. So we have 0, 8, 1, 4, 2, 2, 3, 1. Okay, Julian. Julian.
Yeah.
Up here.
Yeah.
0, comma, 8.
Oh.
1, comma, 4, 2, comma, 2, 3, comma, 1. I'm just pulling points off the tape graph here. Okay, you guys all see where those points came from? Okay, Julian, what's my multiplier?
1. 1/2.
Good. So now put that 1/2 in the initial value into y equals ab to the x, the exponential function there. What does a stand for?
A stands for.
I did write it down on one of the slides. It might have been the first slide I wrote it down. Gabe, what is it?
Initial value.
It's the initial value. So when x is 0, what is my initial value?
8.
So y equals
8.
times
1/2.
the factor of 1/2 to the...
X.
There you go. Okay, questions there? No. Not that it matters. It just means that it's a curve. You know what I mean? As long as you guys have those curves, I'm fine. Okay, last slide. Pay attention. So, Trin, Lee spends $25 each week to pay for his subway pass. Lee has $300 to spend on passes. Is that linear, exponential, or neither? Trin.
Oh, I didn't.
Why is it linear, Trin?
I don't know. I got minus.
Okay, you're going to write the equation then. Why is it linear, Devin?
Because it's talking about like $25 per week, so it's like per 1 week and like more.
So you're subtracting $25 each week, so that's addition or subtraction, right? So, Trin, what is my equation then if it's linear? Okay, what goes into y equals mx plus b? Thank you, Trin.
25. Y equals 25x. Negative 25x.
There you go, you're losing that money. You start with $300 and each week you lose 25. Okay, Ryan, Joe owes his brother $50. He has promised to pay half of what he owes each week until the debt is paid. Be careful here. So, the first week, he owes his brother $50. He pays half of that, and now he's at $25. If he continues to pay half, he'd then be at $12.50. What is it actually? It's exponential. What are you multiplying by each week? You multiply by 1/2. So, Claire, what is my exponential function for this one? Hmm? What are we multiplying by? Yep, we're multiplying by half to the x. Okay, last one. Tim Dog, instead of Tim's dog. I don't know who Tim Dog is. Tim Dog has fleas. I guess so. It's a dog. Somebody decided to name their dog Tim Dog. Has fleas. On the first day, there is 1 flea on the dog. On day 2, the number of fleas has doubled. On day 3, the number of fleas has tripled. Is that linear, exponential, or neither?
That would be.
What? Be careful, guys. On day 1, Tim Dog has 1 flea. On day 2, Tim Dog doubles the amount of fleas, so we'd have 2. On day 3, Tim Dog triples it, so we'd have 6. Is that multiplying by the same amount each time? No, it's neither. I know, I was talking to Devin. He said exponential.
Yeah, that's all the word triple, then that's what I thought that I read.
Good job, Devin.
Okay, Andrew Placencia, you can go get a drink.